Cl2. We start out by counting our what? Valence electrons. Because chlorine is in group 17, how many valence electrons does it have? 7. All right, so 7 plus, and there's 2 chlorine, 7. I need to have 14 total valence electrons illustrated in my structure. All right, so start out by writing your symbols and connecting them with what? The line, which is a single bond. Yes. All right, and then we're going to take away that many electrons.
Which is 2, right?
Correct. Good job. We placed 2 electrons. I have 12 remaining. So, what do I do to get those other 12? Put them around. Yes, work our way outward in, but this is linear, so I don't really have it out. Let's go side to side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So when we look at this, I'm going to circle it just to highlight what we're looking at. Does each chlorine have 8 valence electrons? 2, 4, 6, 8. All right. And then this chlorine, 2, 4, 6, 8. We've made sure that we satisfied all the octets. And we have used all of our electrons. So I'm at 0, everything's satisfied. We can move on to the next one. Any questions on this one? H2CO. So add them up. Hydrogen is 2. Well, 1 plus 1, 2. All right, plus carbon, group 14, it has 4. And oxygen, group 16, 6. So I have 12 electrons that I need to place here. And then I start, after that, by placing the atom, or the element that only appears once in the middle. But there's 2 that appear once. Remember I said C for carbon, C for central? Carbon's present, it will most always be the central atom. Because think, it has the most areas for connections. Carbon in the middle. And it tells us that we have 2 hydrogens connected to it, and then it's followed by a oxygen. So we connect those with our single bonds.
So that's already 6.
Correct. Good job. That right there is 6 electrons. So I have 6 remaining that I need to place. Starting on the outside in, I place those to satisfy my octets. Well, is hydrogen satisfied?
No. Yes.
Because it only takes 2.
Yes. It doesn't have 8, but remember it has a smaller shell. That shell can only hold 2. So hydrogen's satisfied with just that one bond. We never want to put anything else on hydrogen. So where are we going to go to next? Oxygen, working our way outward in. All right. So oxygen's happy. I have placed my remaining 6 electrons. So I'm at 0. Well, what's my problem? Is carbon happy? No, I only have 6. So then my oxygen says, hey, poor carbon, how about I share with you? You don't have what you need, but if we share, then we're good. And so then you form a double bond. Carbon's happy. Oxygen, if we look at oxygen, 2, 4, 6, 8. All of my hydrogens have 2. We're good to go. All right, carbon, how many? Plus, I've got 3 hydrogens. Each of them is 1, so a total of 3 plus 4 plus 6 plus 6 plus 1. All right, and so that gives me a total of 24. And so some of you may be wondering, why is it written like that instead of I've got 2 carbons, 4 hydrogens, and 2 oxygens? Right? Well, what do you think this tells us that this doesn't? It gives us a hint towards the structure. I'm going to have a carbon surrounded by 3 hydrogens attached to another carbon that is attached to an oxygen and another oxygen. And whenever you see OH, that means that hydrogen tails the oxygen. All right, so this kind of leads you into the structure. You are going to become more familiar with this as we continue on, so don't get overwhelmed right now. So, connect everything with single bonds. 1, 2, 3, 4, 5, 6, 7. 7 bonds, so that is 14 electrons. I need 10 more. All right? So, go ahead and place those electrons starting outward in. Well, I don't want to touch any hydrogens, right? They're fine.
Hydrogens are chilling.
So let's go to the oxygen. 2, 4, 6, 8, 10. So I have placed all 10 of those electrons. So I'm at 0. That means I can't add any more electrons here. I just need to check and make sure everything has its octet satisfied. Is carbon happy?
Yes.
Are all my hydrogens happy?
Yes.
Is this oxygen happy? This oxygen? What about my second carbon here?
No.
No. So I need a double bond. All right, but here's the question. Where do I double bond? Do I double bond here? Or do I double bond here?
There. The top one because it's already filled.
You think the top one?
Wait, no, the bottom one because then it would have to.
What if it's both?
No. That wouldn't make any sense.
So you can pick one, but in reality, what they're doing is all of these electrons are floating around in constant motion, and we call this resonance. All right? And so what it means is that one of them may be a double bond at one point, and then they might switch out and say, okay, it's your turn now, double bond here.
So how do we write that?
All right? Pick one. Which one do y'all want, top or side? Let's do the top. All right? And that top one there becomes a double bond. All right, and so what you'll see if you go into higher levels of chemistry, just for some of you that might help you visualize it, you'll see this, an arrow that points here that says, hey, that electron might go back there, and these electrons come here and form the double bond. And that just shows your resonance. That shows where the electrons are moving. You can take any of those lone pairs from that oxygen and move it. All right, questions on this one? All right, step 1, let's count our electrons. I've got 2 hydrogens, 1 plus 1 plus 6. I have a total of 8. All right, the atom that appears once goes in the middle. Oxygen, hydrogen, hydrogen. All right, and then what do I do from there? Connect it with single bonds. And show, let's see, how many did that take care of? 4, so I have 4 left to place. I can't put them on hydrogen, so where am I going to put them?
Oxygen.
Oxygen. And it's happy. Oxygen has its 8, hydrogen has its 2. Ozone. All right, O3. So, starting out, counting our electrons, I have 6 per oxygen, and there's 3 oxygens. So 18 electrons. All right, and then 1, 2, 3. Right? Step 2 tells us, or step 3 actually, says we're going to connect those with single bonds. I now subtract that from there, minus, I just placed 4. I have 14 left. So then what am I going to do with the remaining 14? Put them on oxygen. Starting outward in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Oh no.
So my outer oxygens are happy, but what about my inner oxygen? No, it's missing a set of electrons. Oxygen right here says, here, I'll share with you. But after a while, this oxygen says, it's my turn. I'm going to share. All right? And so what do we have here again?
Resonance.
Resonance, all right? Meaning your electrons are in constant motion. All right? So pick one. Doesn't matter which one. Right? Awesome. There we go. We're going to choose the right and double bond. C2F2. Step 1 is to do what? valence electrons. 4 plus 4 plus 7. So I have a total of 22. Put our carbons in the middle. And then we want to split these evenly. So fluorine, fluorine, because one carbon doesn't want to have to bond while the other one doesn't have to do anything, right? So split them even. Connect them with single bonds. Yes, good job. I just placed 6. I have 16 left to place. Starting on the outward end. So fluorine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All 4 sides have electrons, so we're good. 13, 14, 15, 16. It does not matter. Say you put them both, like, say you just went ahead and put them both on this carbon. That would have been fine. Or you could have put them both on the right carbon. It doesn't matter because guess what? Both of them are going to end up the same here. We never, ever, ever want to use fluorine. All right, we'll go into that in a minute. So we're not looking at fluorine as an option. What are we going to do here with carbon in order to satisfy its octet?
Share.
This carbon says, hey, buddy, I'll share with you if you share with me. Triple bond. Now carbon has its 8, 2, 4, 6, 8, 2, 4, 6, 8, and both carbons are happy. Now, fluorine. Why would fluorine not say, hey, here, you can have 2 of mine, actually?
It's selfish.
Good job, Zach. It is very selfish because fluorine, think about how close it is to having everything that it needs. Standing alone, it has a Lewis dot with 7 valence electrons. It only needs that 1 more to be satisfied. So why would you end up giving away something that you need when you're so close to finishing, right? So think about, if you have $99 and you're trying to get to 100, right? Like 100's your goal and you need to buy something. Why would you give away one of those dollars and now you're back with more to get when you were so close and you just needed that 1 more, right? So fluorine is very selfish like that. It's not going to give away anything more. It just wants to share to get what it needs, all right? So you will never see a double bond on fluorine, chlorine, bromine, or iodine. They all only have that 1 bond, all right? Because essentially they are more electronegative. All right, we'll talk about that as we move in more into the unit. But they're more electronegative, so they don't want to donate any more electrons than they need to. Last one. So here we see CO3 minus 2. What do you see on this one that we haven't seen yet?
2.
Minus 2, yes. Let's go ahead and add it up. Carbon has 4. I have 3 oxygens. Each of them have 6. So 4 plus 18 gives us 22. But then you see a negative 2. So if it's negative, did it gain or lose negativity? It gained negativity. So we have 2 additional electrons. So I need to place 24. That's all that exponent does. All right, when you see that exponent, you then need to adjust your total. All right, so let's go ahead and draw it. We have our carbon in the middle. Then we have our 3 oxygens surrounding it. Connect them with a single bond. 2, 4, 6. So I have illustrated 6 of them. Yes, and I have 18 left to draw. Where do those go on our oxygens? 2, 4, 6, 8, 10, 12, 14, 16, 18. My oxygens are satisfied. Is carbon satisfied? No. All right. And so we never see this. Do not go moving your bonds unless you see that you are at 0, but everything's not satisfied. All right. That's when we can start moving things around. here, maybe our bottom oxygen says, I'll share with you. Here's 2 more. But then the other oxygen over here says, wait, I'll share with you, right? So again, these guys are in constant fluctuation of where they're at, including the one over here on the left, all right? This one also says, hey, wait, I want to share. So it's in constant fluctuation, all right? Maybe our left one comes in and the bottom one goes back. And so we call that again what?
Resonance.
We call that resonance. So go ahead and I'm just choose the bottom one, and you have that double bond. All right, it doesn't matter what side of the oxygen you chose. If you want to use the one at the bottom, either way is fine. But now we see that everything is satisfied. Oxygen's happy. Carbon's happy. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. All right, those circles are just to highlight for you where those are coming from.